Good morning. I'm part of the SIH team for the problem statement of identification of places named from natural language sentence. Um, the system is a geospatial query system where we're leveraging the state of art NLP techniques and fuzzy logic with an efficient database management. The main features in this query system is that we have a multilingual speech to text property, which is one of a novelty, and we have used the transformer model, that is the distilbert model. To be in specific, it is a lightweighted bird model. In this model, it is why we chose distilbert model more than bird model is because distilbert model is more memory efficient, and the computational power is more compared to the bird model. Then we have used customer transformer for fine tuning, and we have used fuzzy logic integration to uh, to minimize the errors, and consider some words even if they have a small spelling mistake. Then we have integrated Google Maps API as well as Wikipedia API. This is the architecture of our project. We have used the front end for web application. So we have used HTML, CSS, JavaScript, Bootstrap, and we have used the user interface of speech to text plus multilingual support. In the backend, we have used Python Flask, as well as we have implemented the NLP techniques. As a resource type, we have Wiki API and a Google API, and we have created our own database for the fuzzy match art. So we go more detail into the code. So as we can see, we have first imported all the libraries, the fuzzy from Flask, Torch. Then we have imported the transformers, the Distilbert model, and we have CSV, Fuzzy Wuzzy, and the translator for the multilingual support. So first we have called out the Flask application, and then here we have load the NER model. NER model is name entity recognition model. It is one of the NLP models to identify a particular name. So now a sentence can be broken down to a verbal phase, a noun phase, a preposition phase, and all, etc., etc. So the Distilbert model over here with this current CSV file has all the places, and it's like a pack of dictionary combined with identifying each word as a noun phase, verbal phase, etc. So if over here we will be able to, in this Distilbert model, we will be able to identify the geospatial name in, especially. So we have created an NER pipeline, which is basically the search engine. So over here, we'll come back to that later. So it takes all the query, and then it converts into a geospatial name, etc. So over here, the fuzzy matching parameter is the similarity. We have taken similarity threshold is equal to 80. Now, why 80? Because uh, in a particular word, we want at least 80 percentage. So we are only taking 80 percentage of the word should show that it's correct. So that is why we are taking a similarity score threshold of 80. If you go less than that, there is high chances that the word itself could be of a different meaning and not of that particular place. So that is why we have taken 80. But with 80 itself, we face a few challenges. That is for particularly for small words. Then we have imported the CSV file, which we have created. So now the CSV file will look like a place, the place's name, like for example, India, the place name, and the canonical name will be India, and the other names will be Hindustan, Bharat, etc. And that place type would be country. So then there can be other places also like this. Mumbai is a canonical name, and the other names could be Bombay, and the place type would be state. So like this, we have created a data set of 20 names for the typing, and that is this data set. So I come back to where we're using the data set, and over here we have used the Flask code, that is a Flask code. where we are taking the get and the post. That is, get is the query we are taking, we are getting the query, and post is printing the results later on. So in this, what when we are typing the query in the search engine, it takes the query and then the results are returned later. So the test is the once the text is taken, we are over here what we're doing is we are aggregating the words and dividing into block and iloc. Okay, now what is block and iloc? So block is like for certain names, certain geospatial names like New Zealand. Now New Zealand has two words, new and zealand. So over here, what we're doing is new will be the B lock and Zealand will be the I lock. So when there is a place which is a one location and it has two words, that would be that entity would be taken as B lock and I lock, so that it can be categorized as one word. Okay, now some words would have a hyphen in the between. Like the same example, as I say, New Zealand has a hyphen in between. This hyphen shouldn't take it as a two word, but should be removed. That is what we are doing over here. If it ends with a hyphen, we are removing the hyphen, and then we are taking the word as B lock and I lock. Now, other words like Mumbai or something, there's no two words. And here, then the Mumbai would be the B lock and I lock wouldn't be required in that such a case. So that is what we're doing over here. Now for fuzzy matching, once the results are taken of the word, we would be that would be the extracted name. Okay, and we are checking if it is a best match. So for that code I will have to go to the next part. This function basically takes the best match is equal to none and the highest similarity is equal to 0. So over here we compare with the fuzzy ratio, that is the similarity score, similarity threshold, where we check that word, the extracted word, and compare it with the canonical name of that canonical name of the dataset which we made, and we also compare it with the other name column, so that even if it is a word, that even if we enter Bombay, which is another name, and Mumbai is the canonical name, the Bombay spelling error can still be identified, and then it will be taken as Mumbai as the canonical name. So then it would return back the best match, and we come back to this column, and if this best match is there in the canonical name, place type or other name, then we would result the append accordingly. So basically print it. So over here we have created links for Google Maps links and Wikipedia, so that once the canonical name is identified, we can map it accordingly. The last part of the code is where we are doing the translation, where we are taking from the post and the method post, and we are translating the text using a JSON file. And what we're doing is whatever text is taken as an input would go to Google Translator, and the Google Translator will translate um, the the text and then give it back to us in English. So that is what we're doing over here. That is the end of the code. Thank you.